The situation involves a homeowner who had an electrical panel replaced by a licensed electrician who is no longer available. An inspector has identified issues with the installation and requires written certification for the work to obtain a certificate of occupancy. The recommended course of action is to reinstall the electrical panel and pull a permit for the job, which is estimated to cost between $1,500 and $2,000. Certifying someone else's work without proper inspection and assurance of compliance carries significant risk. The inspector is requiring certification because the previous electrician did not follow proper procedures. This may include improper wiring, inadequate grounding, incorrect breaker sizing, or violations of local electrical codes. By reinstalling the panel under a new permit, you assume full responsibility for the entire installation. This necessitates a complete inspection of all wiring, connections, and components to ensure they meet current code requirements. This approach provides the greatest level of safety and compliance, protecting you from potential liability down the road. This is the most ethical and professional approach. While it may be tempting to offer a quick fix or a simple certification for a fee, doing so could expose you to significant legal and financial risks if the installation is later found to be faulty or unsafe. If the existing panel is undersized for the load, you would need to upgrade to a larger panel to accommodate the current and future electrical demands of the house. If there is damage or deterioration to the existing wiring, you would need to replace any damaged or deteriorated wiring to ensure safety and reliability. Firstly, a thorough inspection of the existing electrical installation is crucial. This inspection should identify any code violations, safety hazards, or deficiencies in the previous work. Secondly, document all findings with detailed notes and photographs. This documentation will serve as a record of the existing conditions and the steps taken to correct them. Thirdly, create a detailed plan for the panel reinstallation, including a list of materials, a wiring diagram, and a timeline for completion. Fourthly, obtain the necessary permits from the local electrical authority. The permitting process ensures that the work is inspected and approved by qualified professionals. Fifthly, carefully remove the existing electrical panel and disconnect all wiring. Label each wire clearly to ensure proper reconnection later. Sixthly, install the new electrical panel according to the manufacturer's instructions and local electrical codes. Ensure that the panel is properly grounded and bonded. Seventhly, reconnect all wiring to the new electrical panel following the wiring diagram and labeling. Double-check all connections to ensure they are secure and properly tightened. Eighthly, install new circuit breakers of the correct size and type for each circuit. Label each circuit breaker clearly with its corresponding load. Ninthly, test all circuits to ensure they are functioning properly. Use a multimeter to verify voltage, current, and continuity. Tenthly, schedule an inspection with the local electrical authority. The inspector will verify that the work meets all applicable codes and standards. 11thly, address any issues identified by the inspector and make any necessary corrections. 12thly, once the inspection is approved, obtain a certificate of occupancy. This certificate confirms that the electrical installation is safe and compliant. Ignoring code violations or attempting to bypass the permitting process can have serious consequences. Firstly, electrical fires can result from faulty wiring or overloaded circuits, putting the occupants of the house at risk. Secondly, insurance companies may deny coverage for damages caused by unpermitted or non-compliant electrical work. Thirdly, legal action can be taken against you if someone is injured or property is damaged as a result of the faulty installation. By choosing to reinstall the panel and pull a permit, you are demonstrating a commitment to safety, compliance, and professionalism. This approach protects you from liability and ensures that the homeowner has a safe and reliable electrical system. A critical aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ensure that the grounding system is properly installed and connected, including a grounding electrode conductor to a grounding rod or water pipe. Bonding is another important safety measure. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. This helps to equalize the voltage potential and reduce the risk of electrical shock. Another consideration is arc fault circuit interrupters, or arc fault circuit interrupters. Arc fault circuit interrupters are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. Another device to consider is ground fault circuit interrupters, or ground fault circuit interrupters. Ground fault circuit interrupters are designed to protect people from electrical shock. Ground fault circuit interrupters are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. When selecting circuit breakers, it is important to choose the correct size and type for each circuit. Circuit breakers are designed to protect the wiring from overloads and short circuits. Using the wrong size circuit breaker can lead to overheating and fires. Be sure to calculate the load on each circuit and select a circuit breaker that is appropriate for that load. Also, all electrical work should comply with the National Electrical Code, or NEC, which is a set of standards for safe electrical installations. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Local jurisdictions may also have their own electrical codes, which may be more stringent than the NEC. It is important to check with the local electrical authority to determine the applicable codes and standards. Some common electrical code violations include overloaded circuits, exposed wiring, improper grounding, and the use of unapproved materials. Overloaded circuits occur when too many devices are connected to a single circuit, causing the wiring to overheat. Exposed wiring can create a shock hazard. Improper grounding can prevent circuit breakers from tripping in the event of a fault. Using unapproved materials can compromise the safety and reliability of the electrical system. If you encounter any of these violations, it is important to correct them immediately. When working with electrical wiring, it is important to use the correct tools and equipment. This includes insulated screwdrivers, pliers, wire strippers, and a multimeter. Always wear safety glasses and gloves to protect yourself from injury. Also, always turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off. Never work on electrical wiring while standing in water or on a wet surface. Working with electricity can be dangerous, so it is important to take precautions and follow safety guidelines. If you are not comfortable working with electricity, it is best to hire a qualified electrician. If aluminum wiring is present, special consideration must be given to ensure proper connections. Aluminum wiring expands and contracts more than copper wiring, which can lead to loose connections and overheating. Use connectors that are specifically designed for use with aluminum wiring. These connectors are typically coated with an antioxidant compound that helps to prevent corrosion. Also, make sure to tighten the connections properly, using a torque wrench if necessary. It is important to ensure proper wire sizing for the load. The wire size must be adequate to carry the current without overheating. Use a wire size chart to determine the correct wire size for each circuit based on the amperage and the length of the run. If the wire is too small, it can overheat and cause a fire. If the wire is too large, it is simply a waste of money. When running wiring through walls or ceilings, it is important to protect it from damage. Use conduit or cable trays to protect the wiring from nails, screws, and other objects. Also, make sure to support the wiring properly, using cable ties or clamps. If the wiring is not properly supported, it can sag and become damaged. Ensure that all electrical boxes are properly installed and secured. Electrical boxes provide a safe enclosure for wiring connections. The boxes should be made of metal or plastic and should be securely fastened to the wall or ceiling. Also, make sure that the boxes are large enough to accommodate the wiring and devices. Avoid using undersized boxes, as this can make it difficult to make connections and can lead to overheating. If there are any signs of water damage or corrosion, it is important to address the problem immediately. Water damage can compromise the insulation and lead to short circuits. Corrosion can weaken the wiring and connections. If you find any water damage or corrosion, replace the affected wiring and component. Also, identify the source of the water leak and repair it to prevent further damage. It is important to maintain the electrical system properly to ensure its safety and reliability. Schedule regular inspections to identify any potential problems. Clean the electrical panel and remove any dust or debris. Tighten any loose connections. Replace any damaged or worn component. By performing regular maintenance, you can extend the life of the electrical system and prevent costly repairs. And also, never attempt to repair electrical equipment unless you are qualified to do so. Electrical repairs should be performed by a licensed electrician who has the knowledge and experience to do the job safely and correctly. If you attempt to repair electrical equipment yourself, you could injure yourself or damage the equipment.